Hello. Now we will do the MATLAB simulation for the VI characteristics of an SCR. So I'm sharing the screen for MATLAB. It is already opened here. Here it is. We will be needing certain things to create the MATLAB simulation. So first, let me take the things that we need. Then we will create the circuit, connect them, and do the simulation. Then I'll be explaining you the graphs. First, we'll click on the library browser. So we'll get this. Where is the library browser? It is first, of course, since we are doing the SCR circuit, we will be needing obvious thing, Thyristor. Next, it's a Thyristor. Place it here. Then we need a voltage source to give the supply to the Thyristor. So we'll take a controlled voltage source. This is in the electrical sources. This is a controlled voltage source. Okay. Then we'll be needing a pulse generator to supply the pulse in the gate terminal. So there is a pulse generator. Wait a second, please. It will come. Here it is. It's a pulse generator. I hope it's visible. I'm sharing it again. Here it is, the pulse generator, the controlled voltage source, the Thyristor. Then we'll be needing a load, obviously. Elements. There is a series RLC load. Keep it here. Then, according to the formation of the circuit, it should be rotated. I'll right click here. Then the options will come: rotate and flip. Clockwise, yes, clockwise. We will need a resistive load. We'll be using a resistive load. Therefore, we'll click on it, double click on it. Its properties will open up. Once you double click on this one, here are the properties. There is the block parameters. We call the properties of certain of these parameters as block parameters. It is branch type. Series RLC branch will be needing a resistance, so it will be changed to R resistance. Change the resistance from 1 ohm to 2 ohm. Now, what are we going to measure is the current flowing through the branch. Hence, select this branch current, apply. Okay. Let me take the parameters, let me take the things that we need to complete the circuit. Then I will tell what we are going to measure. Okay. First, let me just take the basic things from the library browser. That's it. Okay. Now we'll take a ramp. Ramp. Ramp will be connected with this. So let me place it properly, since you have to connect it anyway. Then we'll take a few things, some of the new things. We'll take some new things that we haven't seen in the previous video. Like we have seen demux and bus selector. We will be needing those things. There is a bus selector. Bus selector. We'll keep it here. Then we need a demux. So keep it here again. And the most important thing in here, most important thing is the scope. One of the most important things, obviously everything is important. In scope, we see the output. Therefore, to see the output, we will be needing a scope, which we will be keeping here. But here you can see that there is only one terminal in here in the scope. Let me increase the size scope for a better view. This is the scope. You will see there is only one terminal. We can increase the number of terminals according to our need. And I'll tell you that whatever measurement we are going to take, according to that, the number of terminals will be increased. Right. Then we need a multimeter. Multimeter, obviously. And two more things, that is power guy. Is the power guy. We'll just keep it here for its functioning. And we will need a new thing that has not been told to you before this in the previous class. Actually, that is we have used demux. This is the demux. We have used demux. We have used bus selector, I think, in the previous class. Now we'll be using mux, a new element. I'll tell you about this one. Mux. So, difference between demux and mux is demux is a single input, double output, or multiple output device, and the mux is double input or multiple input, single output device. Here it is, we have double input. We can increase the number of inputs and in case of mux, and we can increase the number of outputs in case of demux naturally. Now we'll be telling about this. First, let me connect the basic circuit. We simply know that the voltage source is connected to the anode. Simple connections. The cathode is connected to the load here. Here is the completion of the circuit. Now, anode, cathode, this is the gate. It is written G. G will be giving a pulse, input pulse from the pulse generator here. From the ramp will be connected to the voltage source. That's it. Now, this is the simple circuit. Now, for the measurement purpose, we'll continue the connection for the measurement purpose. What we are going to measure in this, what the inputs, the graphs that we are going to measure in this is the gate pulse, the pulse flowing through this, the gate pulse, the input voltage, that is from here. Share the screen again if it's not visible. Okay. The gate pulse, that is the pulse flowing through the this pulse generator through the gate. We'll measure this one, number one. Number two, the input voltage, that is the voltage flowing through this control voltage source. Number three, the thyristor voltage, that is basically the thyristor parameters. Yes, we'll be getting two parameters from the thyristor. Number one is thyristor voltage. Number two is thyristor current. From here, this is the thyristor output. It will be connected here. Number three and number four. Number four will be doing a comparison between the thyristor current and the load current. That is the current flowing through the thyristor from the output and the current flowing through this resistive load. Right. Comparison. So since we will be doing a comparison between the two currents, therefore we will be seeing them in a single graph. Therefore, we will be needing 4 graphs or 4 inputs for the scope. That is gate pulse, number 1. Number 2 is input voltage. Number 3 is thyristor voltage. Number 4 is a comparison between thyristor current and load current. We'll proceed about the circuit later on. I mean, we'll show the graph separately. First, in the first circuit will be doing the comparison. So 4 outputs will be taken. So right click on the scope, go to signal and ports. Number of input ports, it's 1. It will be, since you need more than 3, we'll click on more. It is 4. Okay. You see, we have 4 ports. Now, in the multimeter, we'll be connecting the DMUX. The DMUX will come here. I'll explain the inputs and outputs. First, just let me keep the things that we need. We'll connect the bus terminal with the SCR. So it is given here, and there is the MUX, that is the double input or multiple input single output device. In the multiple input single output device, we'll take the two currents, the two comparative parameters that we will be taking, that we will be checking, the load current and the thyristor current. This first one will be in the thyristor input will be thyristor current, the second input will be load current. I'll show you after this. And these two will go in a single output, will connect it to here. Here it will be connected here. Right. So we will get a single graph for this thyristor current and load current. Now, that's it almost for now. Now let's complete the connections for these devices. From the multimeter, we connect the DMUX. The multimeter connect the DMUX. Here we go. From the SCR, we will connect the bus. Now, and from this, I'll tell you these inputs after doing this, after changing the parameters and inputs of these two, inputs and outputs of these two. First, let me check the properties of the devices I have taken. They can change the properties wherever it's needed. In the ramp, the slope is 1. We will not change this one, it will be same. Pulse generator, it has the time period of 10 seconds. Here it is. The time period has 10 seconds, so we'll change it to 2. We'll after the graph comes, I'll show you the different types of output characteristics of the thyristor depending on the time period. It is 2 for now. This is the thyristor. These are the internal parameters already given, hence we'll not be doing anything about it. Let it be as it is. The resistance R. We have taken the resistance as 2 ohm. We are measuring the branch current, that is the output current, just as I told you. It has already been selected. Okay. Now, the output of the thyristor. Double click on the bus selector. Here we have signal 1 and signal 2. We don't need this. From the thyristor, we will be taking the first port will be thyristor voltage. Taken. The second port will be thyristor current. Click on the thyristor current, select. Apply. Okay. So first one is the thyristor voltage. That is the third parameter that we are going to measure. So thyristor voltage comes to here. Simple. And obviously, fourth one is the thyristor current. Since we are taking the input of thyristor voltage and thyristor current and load current for these two, one of the inputs for the MUX. So one of the inputs for the MUX is thyristor current. thyristor current will come and it will be connected to the first step. Simple. Okay. So now we'll double click on the multimeter. Let's double click on the multimeter. Yes. Wait a second, please. So we'll take the first port of the multimeter as voltage input. So this is source voltage, and the second port as the thyristor current. Sorry, the load current. Let me double click and check. Sorry, you haven't changed the block parameter of the control voltage source. Since we have not changed any block parameter, not taken this one. So see, there is only one input showing. Available measurements on is only the load current. We have to change this one. Since we are taking a DC source, we have taken DC source, and we have not see the reason we didn't have any input for the control voltage source, since we have not selected anything in the measurement section. See, measurement none. We need a DC source, so AC will be converted to DC. Initial amplitude will be 0, since we'll be starting to see the graph from 0. The measurement, what we will be going to measure, we have to mention what we are going to measure. If not, then the multimeter will show like that. So we are selecting voltage here. Apply. Okay, you have to select the voltage of the control voltage source. Now, when we double click on this, see, we have source voltage and series RLC branch, means the current through the series RLC branch, or the current through the resistive load in here. So the first will be click on the control voltage source, select, and the second one will be series RLC branch current, series in the current through the load branch. Click on this. Selected measurements. So this, the first terminal is the control voltage source, second terminal is the load current. Update, close. Okay. This is the source voltage, and this one is the load current. Once we run the experiment, after that we'll have the options of changing the parameters. Actually, renaming the parameters. Oh, sorry, I think we have missed one. Since this is the input voltage, let me just delete this one. The input voltage in the first terminal will be taking the gate pulse. So the input voltage will come in the second terminal. And for the gate pulse, we have to go here. That's it. And this will be connected to here. There is the comparison of the two currents. The two currents will be shown in the fourth graph. Okay, here it is. All terminals completed. Yes, all inputs and outputs covered up already. So we run the experiment now. So we will, once the experiment is run, and once the experiment is run, we will double click on the scope and see the graphs. We'll share the graph with you. If let's say it's not visible, see all the four graphs are together. So we'll separate it using view, layout, four graphs. There it is, four graphs. the legend so that you can understand. See, this is the pulse generator. This is DMAX 1. This is the input voltage. We'll be renaming this one. This is the thyristor voltage, thyristor current, and DMAX 2. DMAX 2 is the load current. Let me change it. I mean, let me rename actually. So this one is the source voltage. Source voltage. This one is the gate pulse. This is the thyristor current. This one is the, what is this? This is the load current. Load current I. What is this? This is the thyristor current. Thyristor current versus load current. Okay. I'll run this again. Double click on the scope. Share the graph with you. I think that is visible. This is the graph. Now let me explain the graph from number one. This is the pulse. This is 2 seconds. We took the time duration for the pulse as 2 seconds. So this is the graph. After 2 seconds, the pulse. This is the first pulse. After again 2 seconds. After every 2 seconds, there is a time period. There is a second pulse, gate pulse, third pulse. This is the input voltage. As you know, it is from 0 to exponentially increasing. Number 3. This is the thyristor voltage. We have seen in the graph during the theory. Let me explain the graph along with the theory. From here to here, see this increasing curve shows the forward blocking mode of the thyristor. The property of the forward blocking property, or the mode where it doesn't conduct. The current is flowing, but it has not started to conduct yet. At this point, the junction 2 breaks. Hence, the voltage drop occurs. This is the voltage drop. From here to this is the voltage drop. After the voltage drop, at this point, the thyristor starts conducting. So this is the period where thyristor starts conducting. Forward conduction. This is the forward conduction. Right. As you see, that the voltage drop occurs at the second pulse. Sorry, at the first pulse of the 2 seconds. When the first pulse flows through, the junction 2 breaks, and after that, whatever maybe the number of pulses given, whatever the input, the gate current is given, no change occurs. Means the function of the pulse, input pulse, is just to break the junction, nothing else. Once it is gone, once the junction 2 is broken, the current will flow normally like this. Now, and the fourth one, the thyristor versus thyristor current versus load current. Thyristor current. So this is basically for the renaming. It's like this, nothing else. 1 and 2. What happens if we don't name them? Here it is. I don't need to name them. We have 2 colors. Number 1, thyristor current is yellow, and number 2, the load current is blue. We cannot see the yellow line. The reason for that is if you see the circuit, the output current, the load current is equal to the thyristor current. Let me share you the circuit again. Share you the circuit. This is the circuit. See the cathode current, the current IC or the IK, that is the cathode current, is equal to the load current. The input current is the summation of anode current and the summation of gate current. IA plus I is equal to IK. So the total input current is equal to the cathode current, the current getting out of the cathode, that is the current out of the thyristor, or IT. IT flows directly through the load. Therefore, the T, that is the thyristor current, equals to the IL, or the load current. Hence, they have basically overlapped. Therefore, you cannot see this. This is overlapped. To avoid the confusion, to avoid this sort of confusion, we will in the next we will do some modifications in the given circuit so that these two currents we can see separately, so that there is no confusion of this overlap. That's it. So for that purpose, let me minimize this one. Well, let me close this one. It is circuit again. Since we are not taking, since we are taking both the currents in two different scopes, so in the two different graphs, therefore the number of inputs will increase. We don't need this one. We need two graphs. Therefore, we don't need this one, since the marks will show the single output only. You don't need a single output. We want two more outputs. Therefore, click on this and press delete. It's gone. Simple. This, delete. We'll be needing these two arrows. We'll keep them for now. We'll connect them when we increase the number of signals or ports. Right click on the scope. Number of signal or ports, we had more. We had 4 ports. Now we'll do 5. It is 5. Okay. So thyristor current will do the thyristor current here. Simple. And the load current will be connected here. Very simple. Everything else will remain same. Everything else is supposed to remain same. We just had a confusion due to the overlapping of these two. So after we do this, again we'll run the simulation. It's done. Double click on the scope. Once you double click on the scope, we'll see. Oh, sorry. Since let me share the screen. This is the scope. These are the graphs. We had previously selected 4 layouts. We need 5 graphs, so we'll be selecting 5 layouts. So layouts is 5. Let me see if we can take the, I think it is visible. I think the graphs are visible, 5 graphs. Let me check if I can put the thyristor, this load current and thyristor current, both these side by side or near to each other, so that we can have the comparison that I was explaining, the overlapping. Here it is. Done. Pulse. The first pulse is the first pulse. Is the source voltage, as I explained. These are already explained. See, the thyristor current and the load current are the same. Hence, let me share the screen again so that there is no confusion. Here it is. The thyristor current and the load current both are the same. Therefore, they were overlapping. Since you have separated the screens, separated the graphs, there is no confusion as of now. Okay, now we'll change one parameter and explain the function of the gate pulse with 1 or 2 more inputs. At the 2 seconds, since the gate pulse, since junction barrier breaks after 2 seconds after the first pulse. Since the input was taken, the gate pulse was 2 seconds. Now we will change that and see what happens if we'll take 2 more inputs in the gate pulse and check what happens after that. Number 1, let me share the MATLAB screen. There's a MATLAB screen. is the get pulse. The time period was given 2 seconds. Now we'll change the time period at, let's say, 5 seconds. 5 seconds. Apply. Okay. Again, after every change of input, you have to run the simulation again. There is the simulated model. Running it again. It's done. Double click on the scope. Share the screen with you. Here it is. See, the first pulse is at 5 seconds. That's what the thyristor, the breakdown occurs at 5 seconds. Simple. Let me take a value less than 5 seconds. We have already taken 2 seconds. Here is the screen model again. Double click on the pulse generator. The time period was 5 seconds. We will be changing to 1 second. This 1 second. Apply. Okay. Run the program again. Run the simulation again. Once you run the simulation again, yes, it's done. Double click on the scope. Now the scope has been shared. See, it breaks at 1 second. See, the first pulse is at 1 second. Therefore, there are number of pulses. There's 1, 2, 3, 4, 5, 6, 7, 8 pulses in our screen. There are more. It will go on. Nothing occurs. See, nothing occurs here. Means once the junction is broken, thyristor starts conducting. Once it starts conducting, there is no use of the gate pulse. Right? Let me take one more pulse. Just verification. We had a period of 1 second. Let me take it to, let's say, 3 seconds. Apply. Okay. Run the simulation again. Double click on the scope. Share. Here is the scope. Share the screen. See, the first get pulse is to 3 seconds. 3 seconds. This 3 seconds. Then there are 2 more pulses. The time period, if I reduce the time period, there will be many more time get pulses, but no change in over. The first only change is here. This is the voltage drop. Once the voltage drop along with this, these are the correspondingly the same thyristor current in the loop. So this is how we perform the VI characteristics of an SCR using MATLAB. Obviously, we were using the marks parameter. We are not using right now to see every single graph separately. Every single. Previously, we have already seen the comparison of both the currents, input and output, thyristor current and the output current, in the same way. In the same graph, not in the same way, the same graph, and this is separate. So that's it from now. You guys practice at home. Closing the meeting. That's it from me.